I am Dr. Mohammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today, I want to discuss about problem solvings on a IPv4 address structure. IPv4 Internet Protocol version 4 address structure. So, in this address structure, while utilizing this IPv4, the protocol, what type of the problems will be arise? How can we resolve those other problems? Here is first the problem is invalid IP address format. While sending the data from one client to another client, if the IP address is an invalid address, we can't send the data effectively. Here the data is a invalid IP address. The scenario is the issue is a user enters an IP address in a invalid format. That is 192.168.1 or 192.168.1. So if it is a invalid format, generally the IP address now which is having the total 5 digits. Here is only the 4 digits is there. 300 is a 1 digit, 168 is another digit, 1.1. So remaining 1 digit is missed. It is a system will be considered as a invalid address. How can resolve this as an invalid address? The solution for this invalid address is now input validation. Implement the input validation to check if the IP address is the correct format or not. And IPv4 address, Internet as a Protocol version 4 address, which is consisting of 4 octets, each range from 0 to 258, which is separated by the dot or the period. So this is the input validation. Now we have to do the input validation. For that now we have to check and implement the input validation to checking if the IP address in a correct format or not. After validating, now regular expression. Use the regular expression. So these are the regular expression, whatever the regular expression we are representing. So to validate the format of the IP address, which is validate the format of the Internet Protocol address. It may be the IPv4 or IPv6 address. So that means in a IPv4 now, generally now we are transferring the 2 to the power of 32 bits can be transferred. 32 bits can be transferred in a IPv4, and in IPv6 now, if you take in IPv6 2 to the power of 128 the bits can be transferred. Bits can be transferred. Here is this IPv4 the structure, the address. Now we can represent importing this RE, that is define the valid IPv4 validation, input validation. Now we will do the input the validation, the variable here, the pattern. Now the representation, this is the representation, the pattern, the representation. So that is R to the power, so that is 25025. This is the size of this the bits, the pattern, and 2 of 024, 0 to 9, 0 to 1, 0 to 9, 0 to 9. So R of 25, 0 to 5, 0 to 9, 0 to 9. So it will be the repeated here. Return the BOL, Boolean values, true or false. So pattern is matched. If the pattern is the matched, whatever the pattern now we are represented, if it is the pattern is matched, whatever the IP address now we are presenting, so it should be in the range of 0 to 9, 0 to 1, and 0 to 4 or 0 to 5. If it is the matched, now it is a valid IP address. And the testing after validation here now will test the printing if it is valid 192.168.1 is valid if it is true, or the print is a valid of the IPO address here is 300.168.1.1 is a the false. Like this now we are testing the validity of the IP address. Now next the problem in IPv4 the address structure here. IP address is in a decimal format. Now generally we are representing the IP address in a decimal format only. Here for that now the scenario we can say it as the first we have to convert the IP address from the decimal format to dotted decimal format. First we have to convert the decimal format. Generally the mission can be understand only the binary mission. So the mission is a which understand the binary the form. The mission binary form is a mission understandable the form. So that's why here whatever the IP address now we are taking here, which is the convert an IP address from decimal the format to the dotted decimal the format. Here is the solution. The solution for that is bitwise operation we are performing. Bitwise operation now what we are taking here, why we are taking the bitwise operation for converting into the decimal format means here the mission is understand only the binary form, that is a bitwise operation, zeros and ones. So by using this the bitwise operation now what we are doing now to extract the each of the octet from the decimal format. So whatever the octets is there, each of the octet can be converted from the decimal format. For that now first we have to define the decimal to dotted decimal. So that is IP at the decimal. The IP address, whatever the IP address now we are utilizing, that IP address can be represented into the dotted decimal, that is 192.168.1.1. It is a dotted decimal and which is written join string IP as a decimal which is greater than I into 8 and x 0 into ff. Here it will be written, and for I in range the 4, if it is which returns the -1. Test the functions. Test the functions means now print decimal to the dotted the decimal. Here it is a decimal number. The converted mission, whatever the mission is understood the IP address. Now which is these are the decimal number can be converted. After converting this the decimal number into the dotted decimal number now, so we'll get the IP address as 192.168.1.1.0 in this other format now we can get. Next the problem is a subnet mask the calculation. Subnet mask the calculation here. The problem is the subnet mask the calculation. The problem is the scenario for that the subnet mask the calculation. We have to calculate the subnet mask given CIDR notations. For example, here by 24. The solution is bitwise the calculations. In the bitwise the calculation now, we have to calculate the subnet mask by shifting the bits. By shifting the bits, moving the bits from right to left or left to right. Here, bitwise the calculations can be done by moving the bits. And DEF EIDR to subnet mask, that is CIDR. Here is the mask. Now we are assigning 1 is less than or equals to 138 minus 1 less than or equals to 32 dash CIDR. That means now the calculation ID, the bitwise the calculation whatever we are doing. So which is returning the decimal to dotted decimal mask value. Here is whatever the 1 less than 32, 1 less than the 32 minus 1 less than, so shifting, that means here 1 1 bit is shifted 32. That means the range of these IP address now we are taking 2 to the power of 32. These are the 32 bits now we are shifting left to shift. We are performing left to shift here. So this is the indication is a 1 left to shift 32. That is 2 to the power of 32. 1 less than or equals to, that means here the less than we are saying it as a shift operator. So this is the shift operator here, left to shifted to the 1 bit. That is now which is subtracted from the CIDR. The calculation here, the subnet after shifting the other bits. Once if it is completed, it will be assigned to the mask. So the mask now, which is having the value of the decimal, now which is written the decimals to the dotted decimal format. So testing the function. So whatever the mask value we are getting here in the form of the decimal, now we are testing. So we are what we are testing here. So decimal converting test can be performing. So these are the converting test now which is converting into the IP address format. So this is the IP address format. Now we can convert into the IP address the format that is print CIDR to subnet mask 24, testing the functions. Problem 4, that is network and broadcast address calculations. Network and broadcast address calculation. Here is if you want to send the data from one network to another network, now we have to calculate the address of that other network, and broadcast of the other network also. Now we have to calculate it. The scenario is given an IP address and these and subnet mask. Calculate the network address and the broadcast addresses. The solution is network address, which is the performing a bitwise and operations between the IP address and the subnet mask address. Broadcast addressing. Broadcast addressing, now what we are doing, perform a bitwise or operations between the network addresses and the inversing of the subnet mask. Whatever the subnet the address is there, that can be inverses, and broadcasting the data. So in the form of the bitwise, now the data can be broadcasted from one server to from one server machine to the multiple client missions, multiple client mission, server mission to the multiple client missions. Now we can broadcast the data. For that, the implementation is, the code implementation is, now we are defining the IP address in the decimal format first. And this decimal format, whatever the decimal format now we have taken, that is a integer type. It is splitted, separated with help of the dot, with help of the period. Now the integer, whatever the integer which we are considering, it is separated by the dot, and it will be listed. That can be assigned to the ports. And if this is the ports I, whatever now which is assigned this the port I, left the shift operations can be performed with 24 minus 8 to the power of I. Suppose I is equals to 1, 24 minus 8 to the power of 1. And suppose I is equals to 2, 24 minus 8 to the power of 2. For I in range of 4. Define the calculate network broadcast IP CIDR, IP decimal, that is IP to decimal IP address. And mask, subnet mask of the decimal here, now performing the left shift operation by performing the bitwise calculations now. So which is converted to the decimal, IP decimal and subnet mask of the decimal. So performing the and operations now that can be assigned to the network address decimal. Here the subnet mask of the decimal, it is the address of the subnet mask decimal. It will be assigned and converted into the dotted decimal. The network address, whatever the network address now we have identified, so that is converted into the dotted decimal. Decimal to dotted decimal. So after converting into the dotted decimal, So it will be the broadcasted. The address will be the broadcasted, and printing the calculated network and broadcast network with help of the IP address and particular the port number of the device. Here also the IP address, server IP address and client IP address. Now communication can be established but after converting the decimal to the dotted decimal. Problem 5. Understanding the IPv4 address components. Here is the question is, the problem is, an IPv4 address is usually represented in a dotted decimal format. So that is such as a 192.168.1.1. So it is a dotted at the decimal. In the dotted decimal, it can be represented. So these are the dotted at the decimal. Now what we are doing. So for connectivity establishment, it is breakdown. Break down these the IP addresses into the binary equivalent. Why you are going to break down to binary equivalent means here the machine can understand only the binary form. That's why now which is breakdown into the binary equivalent the form, and identify the network address for which network now we are going to transferring the data, and host the portion. Host to portion also now we can identify. If the subnet mask is 255.255.255.0. Here is for that one the solution. Now what we are doing, convert each decimal octet into binary form. So here is 192, it is converted into the binary form. Equivalent binary form is 110006 zeros. 168, so it is binary form is 101013 zeros. 1 0 0 0 1 1 0 0 0 0 0 0 1. Here it is a equivalent binary form for this the IP address. Why? Because this is the mission now which is understand only the binary form. So this is the binary form now which is equal to the IP address of 192.168.1.1. Therefore, the binary, the representation of 192.168.1 is so this is the binary representation of the so and so mission IP, so and so mission that means IP address binary representations. So here is the subnet mask also same 255.255.255.0. So in a binary equivalent is here, this is a binary equivalent of 255.255.255.0, and identifying the network and host to the portions. The network the portion, that is the first 24 bits. So that is 1160 zeros, 10101000 and 00001. Here is the host to the portion, last 8 bits. Last 8 bits, it is a host number. 0 is a host to last bits. That in a IP address last bits, first 24 bits are the network portion. Here it is a network the portion, and it is a host to portion. So thus the network address is 192.168.1.0, and the host identifier is a 1. It is a host identifier of the particular the network. So with help of this the identification only, the effective identification only, now we can send the data. If it is a IP address is a wrong format, now we can't identify the device. Whenever it is a correct format, then only we can send the data, we can identify the device effectively and sending the data. Calculating the number of hosts. The question is IPv4 address of 10.0.0 with a subnet mask of the 255.255 no .92. We have to calculate the number of valid hosts in this subnet. So how many valid hosts are existed in a subnet? We have to calculate it. So for given IP address 10.0.0.1 with a subnet mask of this one. The solution is subnet analysis. First now we have to do the subnet analysis by converting the number into the binary equivalent binary form. Here for that now, equivalent the binary form is 255.255.255.192. So in a binary equivalent is this is a binary equivalent. Now for by converting binary equivalent now we have to analyzing the subnet mask and number of host bit, evaluating the number of host bits. How many bits are allotted for the host? There are 6 bits for the host. Why? Because here 32 is the total bits. 2 to the power of 32. 32 means 32 are the total other bits minus 22 network other bits. That is 6 bits are the number of host bits. Here number of host calculation. Number of host calculation, the formula is how many hosts. Now we are going to utilizing the host calculations, the formula 2 to the power of number of host bits minus 2 subtract 2 for the network and broadcast address. This is the formula. By applying this, the formula number of hosts are 2 to the power of 6. That means here number of host bits are the 6 minus 2. So therefore 64 minus 2, 62 host. Number of hosts the calculations can be done. That means 62 is a valid host for the subnet. Like this now, host validity can be the performing. Determining the network address. Network address now, how can you determine what is the network address of the IP address? Here, if they given the IP address and with the subnet mask, with help of the subnet mask and the port number, IP address, now we can determine the network address. First, we have to convert the IP address and subnet into the binary form. Here, this is the IP address. So these are the IP address now we are converting into the binary equivalent binary form. And subnet mask also we are taking. It is also converted into the equivalent binary form. And perform a bitwise AND operations. Performing the bitwise AND operations. So network address, that is a binary. Here is these are the network address now we are converting into the binary other format. Convert the network address to decimal other format. That means here network address is a 172.60.10.6. Here is the network address. Now it is the network address. Like this now, after converting the binary form now, we can convert into the we can convert into the network address the format. Here, so this is the network address the format. Identifying the broadcast addressing. How we are going to identifying the broadcast addressing means now, first we have to convert the problem is the IP address with the subnet mask. What is the broadcast of the subnet? Now here broadcast of the subnet. Now we are going to evaluating. For evaluating the broadcast of the subnet now, first we have to take the IP address of that particular the device. Now which is converted into the equivalent binary form. Subnet also now first we will take the subnet, so that the subnet also convert into the equivalent binary form. Network address the calculations bitwise AND. Network address it is a binary format now, so which is converted into the binary format. So in the equivalent the IP address. Broadcast addressing can be calculated. Here is the invert subnet mask. Add the network address now. So it is a broadcast address of the particular the device. Therefore, broadcast address is 192.168.5.30. So subnetting of a networking. For subnetting the networking now, so you have a network with an IP address 110.10.0.0 and need the create 60 subnets. What subnet should have used and how many hosts can each subnet can be supported. That means now determine the subnet mask first. For that now we have to create the 16 subnets. So U needs 4 bits. That is 2 to the power of 4. That is 16. Default subnet mask for class A. So that is 10.0.0 is 255.0.0.0 8 bits of the network. New subnet mask. New subnet mask is 8 plus 4. 8 is a default value, 4 is a subnet value. Total 12 bits for the network. Now we are utilizing the new subnet mask. Subnet mask, the address is 255.240.0 and calculating the number of hosts per other subnet. The number of hosts per subnets are, so this is the formula. Okay, host bits are the 20 bits. 2 to the power of 20 formula is a 2 to the power of the host bit, that is 2 to the power of the 20 minus 2, and 1048574 is the number of hosts per subnet can be utilized. Here like this now we can calculate. For this topic, the textbooks are Computer Networking, a top-down approach by James. So these are all this is a textbook, and reference book. It is a reference book. The protocol here, the TCP/IP illustrated volume other one, the protocol by Richard Steven. So this is a reference book for this other topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.